Okay, here we go. All right, so for the recording, here's going to be the agenda for today. Part one of the theory, as I mentioned to the group just before, I will be doing more intermediate, not really entry-level stuff for the BGP. And second part, which we'll probably do maybe like in an hour from now, will be the lab portion. Okay. Okay, just replying to somebody here in the chat here. Okay, cool. All right, so first off, why are we going to use BGP to begin with? And I mean, I'm sure most of us here have, at least at the GNS 3 level, have played with BGP. Some of us in here may already have our CCNP, and we're pretty much in here just for like a review, like a second set of eyes looking at this. Maybe you guys are taking a look at this. Maybe you guys are kind of familiar with it, but not really familiar with it. And one thing that I kind of find pretty funny with BGP is that people hype it up to be like, oh, it's the routing protocol for the internet. It's this big mystical thing that's like so difficult to understand and so tough. And in reality, I find this so much easier than actually OSPF. There's not that many commands to run. There's a couple little gotchas which we'll probably go into with the part two. But the basic commands, the basic setup of BGP is really straightforward. And if you know IGP protocols like your OSPF and EIGRP, it's not too much worse than that. So that's the first thing I want to kind of make clear for everybody. It is tameable. It's not that bad. It's just like anything else. You kind of just have to keep at it, and eventually you'll ace the interview questions. Reason I bring that up is because I actually had a phone interview a little while ago, and the guy went crazy on OSPF and BGP. He was asking me and mainly troubleshooting. So if you guys are looking for going on network engineer interviews, they don't want to hear from you. Oh, I know how to do BGP neighborships, or I know how to form. I know how to advertise a network into BGP. That kind of stuff is pretty entry level and basic. I mean, they're looking for more from the troubleshooting point of view, which I'll touch a little bit about today. But going back to my slide here, why to use BGP? In my experience, generally, ISPs and web hosting companies love using it. Most of your single to medium-sized companies, depending on the size and on the business need, may not even need to run it. They may be happy just having maybe one or two ISPs giving them drops. They may have like a WAN aggregator to kind of load balance between the two ISPs, and they're happy with that. But pretty much the main reason a company would get BGP to begin with is to provide multiple ways to get in and out of the network. Meaning that, and more importantly, and telling, I should put this in here, telling others how. And meaning telling others how in a sense of, I want to tell you what's the best way to get in. Oh, actually, I have it down here. You decide which door, and I usually refer to like a BGP domain, like an OSPF domain or a RIP domain or EIGRP domain. Your BGP domain is kind of like a house. I like to picture it. And there's multiple, doors. You probably like a front door or a side door or a back door. And generally, the whole idea between this is like, you know what? I rather prefer people come through the front door than the back door, for obvious reasons. I don't think you want random people coming to the back of your house, as like the main door. Most of the time, it'll probably be the front. So the thing is, if you have a single home or just a single ISP or two without BGP, you could pretty much only tell them like, hey, this is the one way to get out, and that's pretty much it. Now with BGP, you can do, of course, it helps with redundancy and a little bit of load balancing, but ideally, the main reason is you decide which door or which ISP connected to your BGP domain or to your network is the best way to get in or out. And I should put in, into, out of your house, depending on what traffic. So one example is maybe you have one prefix of one network that you want let's say you have like two data centers or something, and you have one network or one prefix that you want people from the New York area to get to, and then let's say you have like another data center like in Europe to get to. You may prefer, if most of your traffic will be coming into the U.S. instead of Europe for whatever reason, you could advertise that out the the New York or the like the New York data center instead of the Europe one, and that's kind of like your way of telling like, hey, listen, even though I own this prefix, I own this public network, I prefer you to come through my New York data center or my New York house instead of my Europe house, or vice versa, or vice versa. Or you could even say something about like, let's say I have one data center in New York. I have two doors. If anybody's coming in for a certain traffic, let's say like a 10 network or 17 network or whatever, I prefer you to go through door A instead of door B. For whatever reason, like maybe internally you have it architectured a certain way and you prefer traffic to go through one door instead of another. So that's kind of like the reason why you would do that, have it in the first place. Okay, so a little about BGP. I'm going to kind of fly through this. Some of this stuff you guys may know already. But once again, I kind of want to go through a little bit of an intermediate review until we get to the labs. And of course, in the chats, if you guys just go ahead, pop in some questions, and I'm sure that the questions probably come more for like the lab portion. But real quick, a little bit about BGP, EGP. I was confused with the BGP and eBGP. There's actually when you get into routing, there's two I guess you'd say it's subdomains, I guess you could call it, or categories of routing protocols. You have your interior gateway protocols and your exterior. BGP is going to be your only exterior gateway protocol, and as the name kind of implies, exterior, outside. So as of right now, BGP is the only protocol out there that's in this category, or you have your really old exterior gateway protocol that's no longer used. And your IGPs, or your interior gateway protocols, it's going to be a choice between these four different protocols here. Most companies use OSPF here. That's like the main, I guess, protocol that they use out there. EIGRP, not too often used. I've seen it once in a Cisco shop because they were all Cisco. But primarily, I've seen mostly OSPF being used. And of course, IS, and RIP, which isn't really too popular, but is a choice for that. And also, when you run BGP, there's a process number that you use to run, which is called an autonomous system number, or AS number. And it must be a unique number when you're running it outside on the public network. So kind of similar to your public IP addresses, you're going to want to have a public autonomous system number, which you can get from the ARIN. I forget what it. Let me pull up the site real quick. It's like American Registry for Internet Numbers is the website right there. And it's actually funny because I did have one interview question a little while ago asking me where would you get ASN numbers. So that might be like a nice fact to have, to just so that you can kind of have it in the top of your head. But that's where you would get your autonomous system number publicly. And of course, just like our public IP addresses, we also have private AS numbers. And the reason, just like anything else, we have a public and private IP address is a way that you could uniquely identify yourself to the rest of the world. Same thing with the house. You have an address where you live right now. That's completely unique to you only. So in the same way, if you own a data center, or in this case, if you own an autonomous system number, you want to tell the whole world that, hey, listen, this is my number here. And that's why, just like your public IP address, you want it to be unique. And of course, for testing purposes, or even, let's say, like internally, you may want a interior or a private autonomous system number. This will be the range here, and these are good for. This is a good fact to know also for interview questions. Also, as well, when you're working with confederations, which we'll probably talk about like at a part 2. These are the number range that you can have internally if you are running in a full-blown real production BGP environment, or even at your own home. Let's say like you're at home and you want to use one of these numbers. But then again, if you're using GNS3, you could probably use you can use AS number 1, and being that you guys are not actually connecting to the internet, it's not going to make that big of a deal. You can still use it. We also have the concept in BGP of a router ID, similar to OSPF and EIGRP, where we have like a router ID that uniquely represents that router. So generally, what we use a route ID, or also known as a loopback interface. Generally, people will use that instead of leaving it up to chance. It's better to hard code a loopback interface to say who's going to be your router ID for that particular router, and that's used to source the BGP packets out. So if you guys remember, there is actually a command source interface, or source interface, where you can actually say, hey, listen, like this is the interface that I want you to exit out of when you're sending out BGP advertisements, or trying to get a neighborship going with another BGP peer. And that's another funny thing too. For some reason, whatever reason being, they don't, at least not that from what I've seen from the different documentation out there, they call BGP peers, so they don't say BGP neighborships or neighbors. They call it peers, but it's pretty much the same thing. So whenever you think of, I know when we talk about interior gateway protocols, we're used to the term neighbors. So you can even kind of translate that over to when you talk about BGP, where they mostly refer to it as peers, but it's pretty much the same thing when you think about that. And this actually, I forgot to put my little top here. Also, real quick, BGP needs something to run on top of. So one big difference from interior gateway protocols compared to BGP is that the interior gateway protocols can kind of pretty much run by itself, meaning that you kind of have like, it's almost like a sandwich. You have a couple of different layers. And let me bring my paint out. So normally, and let's say this is like a sandwich here almost. So you have your router here. This is like your hardware. And normally when you have, let's say in the case of, let me erase this guy. And of course you have the iOS, whatever, I guess I could put it here. Whatever version you're running, like 12.4 or whatever version of the iOS you're running. And then on top of, we're going to do like a router like router RIP, router OSPF, router EIGRP. So that would be like the command you would put here, or the router process, which, we can say something like router EIGRP or something. And it works. I mean, that kind of work perfectly. You can do the neighbor statement. It'll start advertising. It'll shoot out. I know of these networks that are local to my hardware router here, and it works it works fine. But the only problem is with, and then we can say this is interior gateway protocol. But when we talk about exterior gateway protocols, or BGP, because that's the only choice that we have really. And let me kind of erase this over here. We still have of course, our router hardware. So if you're at home lab, maybe like a 6111XM or 2800 series. Of course, you have your iOS 12.4 or whatever version you're running. We're going to have some kind of routing process also running on top. So you're going to have an IGP running, or you can use static routing if you like. And then on top of, now we can say, now we can put BGP on top of that. So BGP kind of needs to piggyback off of some kind of other routing protocol, or some type of static routing in here. So it's kind of like a sandwich that BGP needs to learn its routes. I can't just let it learn it by itself. It needs to it relies on the layer under it to learn and advertise out those routes. Generally, people will use like OSPF or EIGRP, or in small deployments, you could even do static routing, and that works as well. But pretty much that's kind of like how the hierarchy works with BGP. That hence, sometimes you need and this is actually wrong. I don't know. I think that's 159 or 179. Let me double check here. BGP, yeah, 179. There we go. Requirement. And that's also probably like a good interview question as well. Thanks for that, Monica. So yeah, I mean, that's probably one of the reasons why you had that piggybacking off it, because it will use that to figure that out. So in a nutshell, that's pretty much BGP in a nutshell. Of course, I'm leaving a lot of it out, but as I mentioned, I kind of want to skim through the theory for today, do a little bit of a reminder for you guys. But let me let me jump to this slide here. A couple ways actually to keep the BGP configuration clean, or as I like to call it, kind of keeping it clean. This will probably do more in, we'll do this more in part 2. We'll go over this, and we'll obviously, go over some labs involving this as well. Route reflectors, and I don't think, I don't think if anyone's taking their, or has gotten their CCNP lately, or has taken the test lately, but I took mine a little while ago, but they really don't talk too deeply about some of these things. They do mention route reflectors, confederations, they do mention. Peer groups, not really. And one thing that I didn't put in here, address families are not in here as well. And this is when you're running different protocols. So let's say IPv4, IPv6. That's pretty much from what I've seen in the field, the most popular ways to use address families. But this will get more into in part 2 that I want to go over. But as you know, I can go easily. The whole meetup could just be dedicated just to these topics right here. So, in keeping with my 2-hour limit and giving you guys enough time for the labs, we'll put that for part 2. But to kind of briefly skim over this, route reflectors. This is kind of like if you think about the designated router and backup designated routers in OSPF. These are kind of going to be the guy of, instead of having TCP connections between all your BGP routers in your domain, you can pretty much decide to have one person or one router to be the main guy who updates everybody else, and you kind of have a passive or a standby backup designated router, as the name implies, to take over for the updates in case the main one goes offline. BGP configurations, this is where we use sub-autonomous system numbers, or where you break up your real autonomous system into like subdomains or sub-ASs, and this is pretty much where your private ASs get used. So that range that we had before, 6,400 to 64,000 to 65,000, that range over here. Here we go. That's where we will use the sub-ASs for the confederations. BGP peer groups. This is, and you guys correct me if I'm wrong, but I'm pretty sure that at least the CCNP version that I took, they really didn't mention anything about peer groups. But I've noticed a lot of companies do in fact use this, and it's like a template. I have like a set number of configurations that I create a template. I say I want these certain parameters for a particular peer. If I do a peer myself or establish a neighborship to another peer, and whatever, let's say for example, like let's say peer groups or authentications, authentication type or passwords, all that stuff will be already pre-configured, and I can pretty much apply it to a new neighborship or to a new adjacency. And this way, for you, it saves a lot more. Saves a lot more typing, less mistakes, and of course, kind of keeps everything standardized with different peers or different neighbors that you're forming a relationship with. Address families. As I mentioned, this is the way that you can kind of divvy up the different protocols that you're using with BGP, which we'll touch on more for part 2. And of course, we have authentication. Just like what I had in EIGRP and OSPF, where I can pretty much say that you have to give me a password in order for me to become your neighbor. So this way, some random router that pops up isn't going to be basically able to join or I not try to form a relationship with me. You have to supply me some kind of password for me to actually get to that point with you. And I've had to double check that, but I think this doesn't even it doesn't actually encrypt the updates, and I gotta double check myself on that, but it's just the initial open packet that gets sent between the two BGP routers. That's what's this MD5 encryption is doing at that point. But once you actually get the neighborship going, this authentication isn't really used, and I think every I think 5 or 10 minutes it does check to see if you still have that authentication. But probably for in a part 2 lab, we could mess around more with that, so we can check if peering fails if password changes. So that's something I definitely want to do for part 2. Cool. Okay. Next up for the BGP attributes, and there's actually, and I'm pretty sure everybody knows already and I'll put a new slide here for this, the OSI model, the song, I guess you call it, or we have like the 7 layers, and I'm pretty sure everybody knows that acronym that everybody uses to kind of memorize the OSI model. And if I do, I don't know, does anybody know the that song or that acronym that we use to memorize the OSI model? Application, presentation, session, transport, network, data layer, or I think it's like data link layer, and we have our physical. And I'm probably not using the right term, but in terms of song, meaning that, at least when I memorized it, saying that all people seem to need data processing. APCT, yeah. So that's kind of like the little acronym that we use to memorize the OSI model. And in the same sense, I don't think I've seen this on Google or anywhere. I was trying to find like the source for this, but I heard this from somebody. But there's one to actually memorize the BGP attributes. Song, I guess you could say. So pretty much, I mean, just like we have in OSI, wait, preference, if I remember correctly, I think that's what it was. But basically, we love oranges, as oranges mean pure refreshment. I'm not sure if Renee put it in his book, but this is a, if anyone's ever been to genius3vault.com, I found it on his site, and I thought it was actually pretty cool, so I kept memorizing that. But this is almost going to be like you're using the OSI model to, okay, perfect. Yeah, so it's in his book then. And that's pretty much the way that I've used to memorize it. And even though the song is kind of stupid, it just like, you know, all people seem to need data processing. This is a great way to memorize it. So if you guys go to gns3.com and pick up Renee's book, looks like it's in there. But this is the way that we actually memorize the tiebreaker, or the way to find the best path to get from point A to point B. Because pretty much just like we have in BGP and or OSPF and EIGRP, there's mainly two routing tables, and I think I had a. Here we go. BGP has a neighbor table and it also has a routing table, which will actually down in the slide I'll show you guys the command to view those. But same thing with your OSPF EIGRP. We have the neighbor table, which, as you guys can imagine by the name, it's, even if you know nothing about BGP, it's pretty much saying that it's a list of all the neighbors that I know. A BGP table, which, as I kind of have down here, is similar to the OSPF when you like to show OSPF topology. or database. It stores the second best routes. So that's your second table. And the best or the third table, which isn't really it's not really part of BGP, but usually when we learn OSPF or EIGRP, they do mention this as a third table, even though it's not really part of the protocol. But routing table, which is kind of like the winners or the best routes go into this table. So once again, if you guys know already a little bit about OSPF EIGRP, a lot of the stuff carries over to this as well. What else I have? So generally in OSPF, I could even ask a little bit about you guys. What in OSPF, what's used to find the best route from point A to point B? Or what algorithm is run in OSPF to find out like what's the tiebreaker between all these different routes that I'm getting? Okay, well, all right. Well, generally we're going to be using the shortest path first protocol or algorithm that will run. There you go, Monica. Yeah, or Dijkstra's, and I can't even spell it sometimes. Dijkstra's algorithm. Also for, how about for EIGRP? What's the best one for EIGRP? What do we use for that? Metric? Bellman Ford? I think Bellman Ford is actually for RIP. Let me see here. And actually, I barely play with RIP actually, to be honest. RIP best path. Distance vector, okay. Now, just so that, we don't, I'm not making up any stories over here. Bellman Ford. And let's see. RIP. Bellman Ford, a distributed variant of Bellman Ford is using distance vector protocols, for example, RIP. So generally, when I hear Bellman Ford, I think of RIP. And hopefully, am I spelling it right? Bellman. Bellman Ford algorithm. All right, Sharmita. Yeah, Sharmita. Distance vector is actually the type. So if I jump into types of, I guess you say routing protocols, you have your distance vectors, you have your link states, and you have your hybrid / advanced distance vector. RIP falls into this category. Link states would be your ISIS and your OSPF. And your EIGRP lives here. So, Sharmita, when we talk about distance vector, we're talking about more of the type of routing protocol. And yeah, Monica got it down here. dual. And that's pretty much will be like your as you've kind of spelled it out already in the chat there, diffusing update algorithm, which is like your K values. So I think K1 and K3 is used by default, and the other like K2, K2, K4, K5 are not used. And there is a command in EIGRP to check or to change the metrics. I think it's under the interface, and it's like metric question mark, and then I check real quick actually. Not to go off too much off on a tangent, but I'll get 101 shut HRP 1 and the metric weights. This is for a reason. I mean, this command's funny because it says choose 1 to 8, but it says only 0 supported, so I don't know why they kind of have that command in there. And here we go, K1. So this will be the way that you will put that command in there. Metric weights 0 question mark, and then for each question mark you put in here. So let's say K1. Generally, what I found with this is 0 is on and 1 is. I'm sorry, 0 is off and 1 is on. I don't know why you could put 255. Haven't played too much with that, but let's say 1 for on, and you're done. So for each number here, it's like K1, 2, 3, 4, 5. But anyway, let me let me stay on the topic here. But all right, so the reason I bring that up with these guys is, let me pull this down here. This route in BGP, that would be the attributes. So, or generally sometimes we just call them like BGP attributes. And by the way, I'll make these slides available for you guys after after the webinar here. But if and a lot of times, especially for interview questions, I don't know why, for whatever reason, interviewers love trying to trip you up on BGP. I guess it's, you know, once again, one of those like things that they kind of hype up, and I mean, it's not that big of a deal though. And generally, and let me go back to here, attributes. So here's my weight, local preference, locally originated routes, which is one of the part of the deciding factors on which is the best route to go into the routing table, but I haven't really seen it used too much in the real world. AS path, origin, metric. Generally, 1, 2, 3, 4, 5, 6. The first 5 or 6 attributes, I think there's like 15 or 17 total. But generally in the real world, only these two guys are used, and this is used in the real world. So, and really sometimes, I mean, the places I've been at, just local preference and AS path is used. I mean, people don't even go crazy on the other ones. You know, once again, you know, simpler is better in these networks, and the more complicated you try to make it, when it comes time for troubleshooting, it's just more of a hassle. So a lot of companies will try to kind of keep it as simple as possible, even though we have all these different kind of nerd knobs that we can kind of turn around and try to complicate. But this kind of song, if you guys haven't found a way to kind of memorize it, it is helpful. So your weight, your local preference, origin code, AS path, I think this is like locally originated, I think. and the metric, and I forget what these other two. I mean, we never go past down here whenever I do this in the real world. So I'll be honest, I forget what these last two mean down here. But generally, if you could just memorize the first 5 or 6, any interview questions that you go on, and for the most part, you'll memorize fine. I'll put this out here so kind of see. So that would be like a nice kind of cheat sheet for you guys to kind of memorize the order from top to bottom, to learn the different metrics of the for BGP. And I mean, even for someone who's looking at this at the first time, I mean, I'm pretty sure at this point we all know the OSI model. All people seem to need data processing, and there was probably a couple weeks or a couple days where you guys had to sit here and kind of memorize what each one was, what each one does. Is P physical or is a P up here physical? So it's kind of like going back to the basics, kind of the same thing, but we're doing just for BGP. And of course, at the end, at the bottom, I think this is like number 17 or something, like the last or the final tiebreaker is the RID or the router ID, which should be always unique. And I want to say lower is better. Let me just double check that. BGP router ID is a tiebreaker for BGP path selection. Path selection using the metrics. If all metrics are equal, BGP determines the router ID. Which most people hardcode this. Most people hardcode this on their routers anyway. Same thing with OSPF. You hardcode the router ID. You do have the option of going through, as in terms of tiebreakers, the highest IP address of the interface will become the router ID if you don't hardcode it. The highest loopback, and note it has to be the active loopback, and it doesn't say here, but it has to be turned on, that loopback, or I would say like 9 times out of 10 people just hardcode the router ID. We don't leave it to chance. We don't bother going through this process here. I'm pretty sure it's the highest, I want to say. Well, there's something that I want to lab up then. Actually, I think I read it's the highest. If you guys know otherwise, feel free, let me know. But so I'll put it here, my little cheat sheet here. Lab up router ID tiebreaker lab. So as you guys probably noticed, I'm doing this off the cuff, and personally, I like it that way better. I don't want to give you guys canned information or like pre-canned labs. I want to do labs that we kind of figure out as we do this stuff, and and any labs that you guys want to see, like hey Will, like I want to see a lab based on AS path. Let's do it. Let's just make one. Let's kind of put one together. Break stuff along the way. Try to make it work. And the best way to kind of, I think, learn anything is make it up on your own. Try to break it as we go. And I think having it in I guess a little bit of my soapbox here. I think if we actually do this all together, it's one, more exciting because there's more of us here doing it. 2, we get more interaction for everybody here proposing labs, or let's try to type this command in, or let's try to type that command in. And 3, you learn the technology better. And come interview time, that's kind of, on the job, that's what you're looking for. So we'll do that for that. We'll do a router ID lab, and I think I have another one here somewhere. All right, I'll find it somewhere. All right. Anyway, I don't want to spend up too much time here with that, but um, so as I mentioned, try to memorize the acronym or the song for BGP. And trust me, I've been in interviews where I walk in and I'll memorize this. I'll in my head say this song over and over and over. When it comes time for someone to talk to me about it, I already know the order of importance. You know, first we'll do weight, then we'll do local preference, then origin, then AS path, and generally you don't go past AS path. Like for the most part, these four attributes are the only ones that you kind of play around with, or at least that I've seen in my experience. But so real quick, let's just go through these attributes. They're not too tough to kind of think to see what they have or to offer for us. First one, as we saw in the We Love Oranges song, is the weight. Now, weight is a Cisco only feature, and it's only local to the router itself. And this attribute is not advertised out to other routers. So there's a command that we can do in BGP, and I might as well jump to it over here. Show IP BGP, and another good thing also, guys. When you guys are learning the BGP commands, and there's not that many. I posted on this PowerPoint here, you know, at least half, if not more, of the commands that you'll do over and over and over when you do BGP administration, and they really don't change. It's the same 5 commands over and over and over, and we'll get into like the advanced stuff like route dampening and atomic routes and atomic aggregates and confederations. We'll do it next time. But just to give you guys like an introduction and into it, I kind of want to lay the foundation here of the commands that we'll use over and over and over. But in this output here, show BGP, I'm kind of skipping a little bit of ahead, but this command is to view the BGP table. It would have been nice if the command was show BGP table. I think that would have been, that would have made more sense or something, but unfortunately, it's just show IP BGP. And if we take a look down here, we have a metric column, we have a local preference column, a weight column, and a path column. So this is something that, as we can see here, this is the weight out of the box, 32,768. And if I remember correctly, this is actually the same default value that spanning tree gives. When it tries to calculate, that's one of like the default values it has. But that's like one way that you can check what the weight is for a particular network, or prefix, as we call it in BGP. But as I mentioned, this is a Cisco only feature, so I mean, unless you guys have seen differently, I've never seen the weight being used. It's just one of those gotchas that interviewers love to ask you, saying, what is weight, and they'll try to trip you up and say, oh, can I use weight between a Cisco router and a Juniper router? And your answer is no. Say no to that because it's a Cisco only feature. And once again, it's local to the router. Local meaning that it never leaves that particular router. It always stays locally here. It doesn't get advertised out. In this case, higher is better, and meaning the higher route gets installed into the routing table. And this actually affects outbound traffic, which is kind of a little weird. But if we take a few minutes to think about this. So if I look at my diagram down here, and I'll paint this a little bigger so you guys can see it better. So I got routers A, B, C. Routers B and C up here are in Autonomous System 200, which by the way is a real autonomous system number. If you guys want to lab this up, you really could if you want to. And then down here we have router A, and he's by himself in Autonomous System 100. So AS200 is telling me that he owns the 172.16.10.24 network. And being that these two routers know this network, they're and actually, if just to give you guys a quick question, what kind of relationship is between routers B and A? I mean, what kind of peer or neighborship is going on between these two routers right now? eBGP. Yeah, there you go. See, perfect. All right. That's why I didn't want to talk about eBGP and iBGP, because I think I'm preaching to the choir. I'm pretty sure we all know that at this point. But if you guys don't, don't feel bad. Like, feel free to shoot me a question. I'm just trying to make the best use of time right now. So, but yeah, so we got our eBGP neighborships between B and A and C, and chances are that we have an iBGP between B and C. So right now I'm advertising out down, as you can see from the arrows, that B and C own the 172.16.124 network. But according to this, router A is going to prefer going to router C instead of going to router B. So picture AS200 being a single home. I have two doors. Router B and router C are my doors. I can walk in two doors. Now I have this line here that says this affects outbound traffic. So pretty much from let's say I live in house 200 or AS200, and I'm telling somebody else, let's say I'm telling my neighbor next door, he lives in house 100 or AS100, and I'm telling him, you know what, Mr. 200 or 100, Mr. 100, I want you to come. If you're gonna come to my house, come through the front door. Come through router C, which is my front door, and router B is my back door. So I will advertise out, in this case, and the weight will generally be on your edge routers, going out that says that I have a route here saying that I have, actually, no, I'm sorry, on A, because it's local. I was thinking of local preference. A, that any routes that I get from C, give it a weight of 100, which, by the way, is the default if I remember correctly. I'll double check that. Actually, no, it's 2027, I think. I gotta double check. Let me double check that actually. Default weight BGP Cisco. Yeah, I was pretty sure it was 100, but let me just double check that because I'm wondering why this output screenshot that I have here shows 32,000. Worst comes to worst, I go to the config guide, let me do weight, and usually it says in here something. Weight is a number, blah 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 blah. Which can be associated. Any path on a Cisco router originates will have a default weight of 32,000. Other paths have a weight of 0. So it looks like 32,000 is actually the default. Let me load that up real quick. I'm actually curious now. Let me put two side by side. We should be able to do BGP fine since it's like a point-to-point link. I'll say 2. Actually, no neighbor. I'll say 1. Remote. There's 2. Actually, this might conflict with. Yeah, it will. So let me. So this is 2. If you guys don't know these commands yet, don't worry about it. We'll, as I usually say, you learn best by doing. Neighbors 1, idle. I may have to do that source command. It's been a while since I've done this. Let me just take a look at the config guide here. Oh, updates. There we go. Alright, so I'll probably have me do the interface. Now I'm really curious. See, now let me do. I'll do another one here. What is the default weight? Okay, Monica's saying the default weight is actually for local preference. Yeah, that's not. I knew that 100 sound rang a bell. According to the documentation on Cisco, it said looks like 32 is actually the default. So let's actually take a look at local preference real quick. And as you figured, yeah, default local preference is 100. And of course, we can change it up. Here's a command for that. And by the way, guys, this is something that I use constantly whenever I'm learning something new. Granted, this is pretty long, but just type in Cisco anywhere on Google. Just type in configuring BGP Cisco, and you'll get. In this case, this is the config guide version 12.2, which will pretty much work anyway. But this is just a big laundry list of all the different options that we can do with BGP, or most of them at least. So in this case, as I just kind of gave you guys an example of, I'm like, all right, wait, I need to learn about weight. So there's a section here called configure weights. Click on this guy, and you get pretty much all the commands. Kind of explains to you the default weight, different ways that you can configure it. Doing with route filtering, which I want to do actually next meetup. I want to do more of this kind of advanced stuff here, but there's always so much you can learn by videos, by CBT videos. So let me paste that into the chat window there. It is pretty helpful to like read the documentation. So I'll do that too for the weight. But let me go back down here. So in this case, I changed the weight to 150 for any routes coming from B and C. So in this case, we said that higher is better, or the weight, the higher the weight, the better it is. So in this case, in my routing table, I'm going to put the route to get to router C as the best way to get to this network, 172.16.1.0, and into the BGP table as like kind of the second best way. I'll install the path to get to router B. So that kind of will be like a way that we will use weight. But as I mentioned, I've never really seen weight really being used. Mostly it's been local preference. So in this case, local preference is kind of similar to weight. Like weight, the higher is better. So as Monica pointed out, 100 is the default. That may be good to know. Maybe for the exam or in the real world. And this we figured out was like 32.768, I think it was. And this is kind of similar to what we had locally. This is something that's local to my autonomous system here. But local in the sense that it doesn't go, it's not going to go across to my different autonomous systems, but in this case, it does get advertised out to other BGP routers in my BGP domain. So unlike the wait, which stayed locally on A, the local preference I can actually advertise out to B. So it learns that this route, to assign a local preference of 100 or 50 in this case, and it'll kind of go back and forth between the BGP routers in your domain. So kind of similar concept, where I have two routes coming in. Same example as we had before, the 172.16.10. They're coming down here to A and B. A and B both have local preference set saying that anything I learn from C, give it a local preference of 50. Anything coming in from D, give it a local preference of 100. And as we saw, like wait, higher is better. So the route to get to router D from B will be put into the routing table as the best way to get to that particular network. And from C to A, that'll be good. That'll just go into your BGP table or the show IP BGP command as a second best route. So when you think about wait and local preference, they pretty much do the same thing, just as Cisco loves to do. They'll have one as their proprietary way of doing things, and then you kind of have like the industry standard way of doing things. Next up, I have my metric or MED, aka the multi-exit discriminator, but pretty much people just call it metric or med. Yeah, if your eBGP peer accepts this, or in the other domain, it will tell the other AS the best way to get into your house or into your network for the advertised prefix. And one thing to memorize with this though is that lower is better for this, and that meds get advertised out of the BGP domain, unlike that we had for wait. So in this example down here that I have here, I have AS, once again, AS 100, 200. I got my 172.16.10 example again. In this case, as we mentioned, I have here going down, advertising to AS 100. I'm advertising out, okay, to get into this house, or in this case, this domain here, or this prefix, I'm shooting out the prefix with a metric of 10 down here into 100, and from D, I'm shooting down a med of 5. Now, we did say in this case lower is better, unlike we had for wait and local preference. So AS100 or my neighbor is going to think, hey, in order to get to this guy's house, I'm going to take this door, because he's telling me that this door is the best way to go through. Because I assigned here a metric of 5, and here's a metric of a med of 10. So the key concept here is to think that lower is better. But it's kind of similar to what we're thinking with local preference and wait. We're saying what's the best preferred path. And actually, let me go back here because I don't think I fully explained this here. This affects outbound traffic, meaning that even though our networks that are coming in to my network are getting assigned this wait, ultimately it actually affects things going outbound, because if I'm saying I prefer going out to router C instead of router B, in essence, I'm really affecting outbound traffic, even though it looks like inbound traffic. And just to give you guys a sneak peek, that's where I have this chart here. And this is actually pretty helpful to know. If I adjust the weight, high or low, or like kind of what's the tiebreaker, what's the best one, the highest weight is going to win. And ultimately, this is going to affect traffic going outbound, because I'm saying traffic coming in, even though it looks like it's coming in and it's being assigned a certain weight, in essence, I'm really affecting the outbound traffic that my internal domain is going to be specifying. So an AS path is actually going to be affecting inbound traffic, because I'm telling, where am I here? Oh, my med here, inbound. So this is actually affecting my inbound traffic in essence, because I'm telling the rest of the world what's the best way to get into my preferred or my specified prefix. Actually, let me skip through origin. Let me do A as path. Actually, yeah. Let me do origin. Okay. So with BGP actually origin, the main idea to be asking with origin is how did the BGP learn this prefix, or how did I learn this prefix? One of the ways that we can, if you guys have been playing BGP for a while, you may have seen, or you definitely seen this. It's when you issue a show IP BGP to view the BGP table. And if I use this command here, you can see here as well, show BGP, and right here we can see the suppressed, damped, history, valid, best, which part 2 for this meetup, I want to explain more about what these mean and how we can get our routes to show these parameters. But generally, for the most part, you'll just see either an I or a question mark. I will stand for, I learned this from a route from an interior gateway protocol. As you can see down here, I have a few I's over here for these particular prefixes. EGP is no longer used. So if you see, as you can see from this output here, I don't see anything that says E. That's if I learned it from a literally the eBGP protocol, which we're not even using anymore. So you should probably never see that ever being used. Or incomplete, which is a question mark. And from BGP's point of view, it pretty much says that I have no idea how to learn this. It just popped up. It just came into my BGP table, which in this case I don't see anything here. But generally, from what I've seen, it's being redistributed from an interior gateway protocol. Whether you do like redistribute via like a prefix list or a distribution list, or just straight up like redistribute static into BGP. Okay, and even when you have multiple ways to get to a certain prefix, and you have, what way is best, it's kind of like you can think of like a rock, paper, scissors. Question mark beats exterior gateway protocol, and exterior gateway protocol beats interior gateway protocol. So when we get into labs, you'll kind of see that more, that sense. So what are we doing right here? Here, for example, I have two. Oh, actually, no. Yeah, I have two entries here to get to this particular network, 10.1.0.0.24. And the little arrow here is the best path to get to that network. So let's say next hop, which is my default gateway here, is the best path to get to 10.1.0.0. Because, well, actually, it's kind of a bad example, actually, because it's the next hop. But let me see another one here. Yeah, let's do 10.97.97.0.24. I got three ways to get to this particular network. In this case, I am choosing this one right here. And local preferences is set there. The weight is 0. So weight is lower, which is an A is path here. We can see path. They don't put it in A as path. They just say path. 1, 2. We got 2 hops. And chances are it was redistributed because I see an I over here. So that would be the best way to get to this particular network here. But as I mentioned, when you guys actually do this in the lab a little bit today, you'll see that better. And finally, I want to go through the last attribute that most people use, which is AS path. And as I kind of alluded to down here, where I had the column here of path, the network or the prefix that goes around a BGP domain will leave a path of like the places that it's hit. It's almost kind of like a hop count. So when a BGP router sees it in the path, it's meant as like a loop prevention a way to like prevent like loops in your BGP domain, or in this case the whole BGP router, the internet routing domain, it'll reject the route. So if I look down here, if I have a route here that was advertised from AS1, goes to AS2, goes to AS3, and comes back to AS1, it's going to ultimately reject that route, because if I see the trail of, and generally it'll be, let's see, this will be 1, 2, 3, 1. If it sees that 1 again, like a duplicate, it'll be like, it'll say to itself that I've seen myself in this path or in this trail, so there's no reason for me to keep advertising this out, because it means that I'm going to go 1, 2, 3, 1, and it's going to be at this point suboptimal. You're gonna make more jumps than you have to route this to get to this particular network. So I'm just gonna go ahead and reject that route. All right, so keep on clean. Went over this already. Okay, so some of the commands that are as I mentioned, these like 5 or 6 commands will be used. You'll pretty much use constantly over and over and over again. Of course, aside from the the neighbor commands and the remote AS commands, these commands will be the ones that you use as your day-to-day administration, time and time again. So knowing what these commands are doing, being familiar with the output, will be pretty helpful here to know. So once again, as I mentioned before, this show IPBGP, as I said, I wish they pulled a table, because that would have made a lot more sense, but they didn't. So this is to view the BGP table, and a couple things here that we can see is my router ID. So I can see that right here. Local router ID is 172.31.11.1. I can see my columns here, so the most commonly used attributes like the metric, the med, local preference, the weight, the AS path are here. Next hop, which would be the next way or the next jump to get to this particular network that I have. In this case, 10.1.0.0.24. So I have 2 ways to get to that particular network. Or I could even say, to be more specific, this is to view the, I can say here, entire BGP table. Or I can, if I want to be specific, and a lot of commands in the iOS let you do this, show BGP and then put the actual network that you want to view. And that will actually give you more detailed specifics on the network, which kind of look like, I think I have a, yeah. And it kind of looks like this. So you'll see more details about this network. So it'll tell you like the metric, the origin, this is the best path to get to this guy. Paths, I have 2 available. There's only one best one right now for this. So you can either see details about a particular, it's almost like you're doing like detail, like a detail command for that particular network, or you can just do, I want to see the whole entire thing. Next up is BGP summary, which is kind of like a way of like a summary view to view your neighbors, which is kind of weird because this I have, I mean, I wish they would have called it BGP neighbor summary. I don't think there's a command called that, so unfortunately, once again, I think the biggest thing with BGP when people first start learning it, they kind of get confused what the commands mean because they're not really intuitive. I mean, if I see this, I'm thinking, you know, let me just see a summary of the routing table or something, or the summary of the BGP table. Not really. In this case, you're actually looking at the summary of or my BGP neighbor summaries. So a couple things to take a look at here. I can still see my my router ID. I can see my AS number here. Down here, which is what I want to see, is what neighbors I'm with right now, or I'm established a neighborship with. Their AS number. Messages sent, messages received. This is good for troubleshooting. How long it's been up, how long it's been down for, and how many prefixes have I learned, or how many networks have I learned from that particular neighbor. And I put this guy up here because if you take a look at the state here, depending if it's up or down, and once again, if you guys are doing interviews or troubleshooting, this is really helpful to know. If it's under something other than a number, like it says active, that's bad because you're not actually, in this case, you can see here, 0 sent, 0 received, up or down, it never happened. Right now I'm in an active state, or I'm actively trying to form this neighborship. You know right now, I mean, I don't know what router are here, the 172.12, 1231 network, neighbor 333, it's not happening. It never came up, and it's in an active state. So this is like a big red flag for somebody who's troubleshooting, to know that something's wrong with this neighbor, and to kind of take a look at the details of that. Or if you have a number down here, you know that you're fine. A little bit more intuitive command this time. Show IP BGP neighbor, and you have to type in the route of the neighbor, or the IP that you're using actually to get to him. So this is kind of blown up a little bit here because there's a lot. This gives you a lot of information when you're troubleshooting. Some things here you can see is the keep alive, the hold time, which I believe if they're off, the neighborship won't form up. But more importantly, once again, when you do troubleshooting, take a look at the sent and received. If you don't see these numbers incrementing, or the keep alive, if you don't see incrementing, you know something's up with this neighbor. So once again, this is kind of like more of a troubleshooting, example, or a command to use. And if you look down, actually up here, at the third line where it says BGP state enabled or established, this is good. This means that the peer is 100% up. If it says otherwise, it's either in the process of going up, or there might be some trouble on the other end. Show IP BGP I talked about a little bit already, so I'll kind of skip through that. BGP commands that we could also use is, and these also, once again, these are questions or questions that you might get in an interview that are pretty helpful to know. When you put show IP BGP neighbor and you add on here the advertise routes command, or routes command, right here it says what routes am I sending to my neighbor of 1111. So down here I kind of have a little bit of an output of that. These are the networks that I'm advertising out to this particular network, or to this particular neighbor. And down here I'm seeing what routes am I getting from 1111. I can say show IP BGP neighbor and just change this to routes. And it'll tell me the flip side, which we can see down here. It'll tell me what routes am I getting from that particular neighbor. So once again, this could be good for troubleshooting and to kind of get more under the hood of what BGP is doing. Okay, I went over this real quick, so I'm not going to go through it too much. All right, so that was more of the day-to-day stuff. A couple of the maintenance commands, I like to call it, or the stuff that you use to fix BGP when it's not acting the way it should. You can do this command is pretty dangerous. Of course, you don't want to do this in production, only in when you're doing labs. Clear IP BGP star, which pretty much blows out, basically kind of blows out BGP, and you start fresh. So you lose all your neighborships, you lose all your routes, you start fresh. But chances are, in the real world, you're allowed to do a soft reset. And you can do this, which is only going to restart a particular neighbor, soft out. So basically kind of what this does is re-advertise out your routes, hence the word out. So for this particular neighbor here of 1111, if the other peer, let's say I'm peer to like 2222, if like whatever reason he's not getting my routes, or he's not able to come up for whatever reason, I can say soft out, and it will re-advertise my routes to that particular neighbor. Down here, I'll have the same deal, but instead of specifying a particular neighbor, I can do it for everybody, which, like I said, in the real world, you probably want to stay clear of the star. You want to specify who you're doing that for. Okay, and on the flip side, it's literally the same command. We can use a star, or we can specify a particular neighbor. In will be inbound, so it'll request for the other side, and once again, if configured, if they allow it, you can request the other side to resend their routing information or their advertised networks to you without killing the neighborship. So that's good. It's kind of like a route refresh or a way to kind of hit F5 on that page to repopulate what routes that you have. And one good way to actually verify that is issue a show IPBGP neighbor and see that the route refresh column is set to shows 0 received and 0 sent. So that's a way that you know that you kind of hit the reset button on that, and you're starting from scratch, and you can, now you're 100% sure, that in fact that this command took. Okay, and finally I have a couple of debug commands here. These are a couple of the commands that I personally used in the past. Try never to use a star. Only do this in labs. So like lab only, because that'll give it a lot of information. But generally, these 3 commands I've used in the past for troubleshooting BGP, events, updates, and keep alives. So in the labs, you can pretty much do. Actually, sorry, me up here. Lab only. Debug IPBGP, which will give you all the debugs. And this way, under the hood, you can see what's going on when BGPs are forming neighborships, sending routes to each other, doing MD5 authentications. And it's pretty helpful just from a learning perspective for those commands. Okay. So you guys have any questions on that? I mean, once again, I knew I flew through this already. I kind of went fast. Just in the interest of time, I want to kind of keep things going and as a review. So before I pass this over to Jose, does anyone have any questions about kind of what I went over or any mistakes I might have made? No? Okay. Great. All right. I hope you guys, if anything, more than anything, I hope you guys got a refresher out of this. I know personally for me, I've been working with Nexus a lot lately, so I haven't done BGP in a while, so it was a good refresher for myself. But ultimately, it shouldn't be about myself. It should be, hopefully you guys got something out of this. But let me pass it to Jose, and let me kill the